Alright, guys. Last chapter. Unit 6. So, continuous probability and discrete probability. So, I'll probably whip through a couple of these on one video because there's not much to this. Then it gets kind of interesting at about activity 3. So, we're looking at continuous and discrete probabilities, or variables, sorry, first. And all really the difference between the two is discrete is counted and continuous is measured. So if you have anything that has to be a whole number, really, then it's going to be discrete data. So like how many tomatoes are on that plant? How many siblings do you have? What, how many this, how many that? Okay, those are all counted. That is what we call discrete data. When you're measuring something, time, temperature, even money to some extent, height, weight, all these things that are measured are called continuous data because they can have any value, right? Like you don't go from 3 seconds to 4 seconds. You go, there's tenths of seconds and hundreds of seconds. So time doesn't jump from one value to the next. It's continuous. So that's continuous versus discrete data. We're going to play around a lot with continuous data as we move forward. When you look at these graphs here, these tables, they talk about the probability of something happening. So there's not much here really. This guy here is going to be someone we're going to be used to, okay? As far as shape goes, but there's not all that much in this. If you want to know how many people are right here, if we're looking at the age distribution of teachers, and you want to know what percent are between 30 and 35, that is 14% of the population is this bar here. So if you wanted to know 30 to 40, what you would do is add these bars together. One way to think about this is that this has a total area of 1 or 100%, and each of these now, if you consider this 1 as a decimal, right? So all the percents add up to 100. Change that from a percent to a number, like we talked about probabilities being a portion of 1. This is 14% of the area. This is 14% of the area. This is 14% of the area, right? So when you figure out the probability of something happening, it's the area under the curve or under the bar here. So if I was to shade in, these 3 bars and somehow I could measure the area of these 3 bars, it would be 14%, 14%, 14%, 42% of the shaded area would be in these 3 bars. So that matters as we move forward. There's not much else really with this unit, with this section. So I'm going to move on from that to the next one. And again, the next one isn't that heavy either as far as content goes. This is the frequency polygon. So that's more of what I've just been talking about really, is that what you do is we can go from having bars and histograms to drawing a smooth curve through the line. So this video here kind of shows what happens here. And what you do is you take the bars and kind of shade them in and make a curve out of the whole thing. So you end up with what we call the normal curve. So even though these bars don't make this nice normal curve here, so it goes like this up and down, right? That shape is symmetrical both ways, right? It's symmetrical, through the middle. So in reality, even though the bars aren't exactly symmetrical, if they look like they go like that, right, you could draw a curve like that. They max out the mean, the median, the mode, the central tendencies are all in the middle here-ish, right? I don't use the word middle, but they're here and they're the tallest bars, and then it gets lower. We find that many things that we measure follow roughly this pattern. Heights, CO2 emissions, I guess in this case, ages of certain things, results on tests, a lot of things, birth weight, they tend to be more common in obviously with the mode, but even the median and the mean and the mode are all right here kind of. And then as you go to one extent and the other extent, they get thinner and thinner. So for example, if this was height of an average male in Canada, this might be 5'10" here. The biggest bar is 5'10", 5'11", give or take, right? And then you get here people over 6'2", 6'5", and then over here you would have, people over 6'9". So very small percentage. And on the other side here, you'd have the shorter people here, 5 feet, 4'10", that sort of thing. Okay, so that's what a normal curve is. And that now leads us to the fun stuff. So once you get to 6.3, this is where we get the normal curve, and we're going to do standard deviation for 6.3. I'll try to get that in this video and do some of the homework. And then in the next video, we'll do 6.4, which is z-scores, which I find really fun. So in the normal curve, what we realize is when you have the normal curve, and you can play around with these videos that they have here, but this is the gist of it. When you have a normal curve, and this is what we call this, it maxes out at the mean, around the mean. And then what we figured out is you can figure out the standard deviation of this curve by doing the math that we did earlier to find standard deviation. And what we find is that 68% of the data is within plus or minus 1 standard deviation of the mean. So if you know what the mean is, and you go out 1 standard deviation in this direction, so plus a standard deviation, and then if you go back this way, minus a standard deviation, so this area right here is roughly 68% of the data, give or take, okay, on average. So we use that, and we're going to use that for some questions. But furthermore, 2 standard deviations away, in this direction and this direction, so plus 2 standard deviations and minus 2 standard deviations. So this part of the curve, all of this here, is 95% of the data. So 95% of the data is within 2 standard deviations. If we go out to 3 standard deviations, we find that almost everything, not everything, but 99.7% of the data is within 3 standard deviations. What we do in this section of the course is we kind of, we're going to do these questions based on this math. And what I've done here is I've added this little thing that I find pretty useful, is now if we know that this is 68%, right, between, so if I go back here and I say, and it says here that 68% is from here to here, that if this is 68%, then this chunk here is 34 and this chunk here is 34. So this will help you with your homework questions when you work on them. And then if I know that this is 95%, and this is 68, then I'm left with, if I take 68 away from 95, I'm left with 17 or 27%, sorry. That is equally distributed between this piece here and this piece here. Okay, so this is 68, all this is 95, 68's gone, I'm left with 27. Cut that in half, and you can see that's how I get 13 and a half, 13 and a half. Okay, and then if you do the same thing with the 99.7, you end up with 2.4% for this strip and 2.4% for this strip. And then we pretty much have 0.1 here and 0.1 there. It's not exact, but that's what we're going to go with. The next thing we also know too, so when we do these questions, is even though this adds up to about 50%, if you add the strips up, we do know that if you just look at each half, we're at 50%. So now let's look at some of the questions. So we're going to go back to this as we look at the questions here, and you can play around and watch this video. These are great. Okay. Once you get to this question here, what's the probability of this happening? Okay, so let's get the data here. The mean is 150. We're talking about potatoes here. The standard deviation is 20. And the question is, what's the probability of this and that and all that sort of thing? So I have put this on. Give me a second. Put this for you here. So the first question is, what's the probability that we're less than 150? So 150 is your mean. So I always recommend to anybody who does these to draw a little sketch, a normal curve like this. The mean is in the middle, and then you just shade in the area that you're concerned with. So 150 is in the middle, you shade this in, and we know that the part that's left of the mean, okay, so we just got to be careful here. When we do this, that we have the right question. Okay, so the first question is, it's got pushed up on me here, let me see. Where'd it go? Right here. So first question is the probability that less than 150, is here, that's 50%. The next one says, what's the probability that you're less than 130? So if I look at this, less than 130 is on this side here. That's 1 standard deviation over. So if I go back to this guy, you're going to see that I drew this in here. No, sorry, I did it over here. Sorry. I think this helps. Okay, so if you have, where'd it go? Give me a second here. Where did I draw it? Where did I have that? Give me 1 second. I'm going to pause. Okay, I don't think the picture actually worked here. So this is a good opportunity. Actually, we'll work on it together. So this is, I just cut and pasted this. This is the general curve. But let's put our data on here and show how this relates to the potato situation. So we had a mean of 150. So give me a second here. Just got to be able to draw on this. A mean of 150. So 150 is our mean here, right? So that's there, and the standard deviation is 20. So if I add one standard deviation here, I get to 170 because I'm adding 20, 190 here, 210 here. So I'm adding 20 each time. From the question, mu is 150, sigma is 20. And as I go backwards here, by subtracting sigma, so 2 sigmas is subtract 40, and I get all the way here. So if question number 2 is, what's the probability that I'm less than 130, I have all this here. So less than 130 is over here. It's 1 standard deviation over, but it's less than. Okay, so there's 2 ways to do this. One, I could add 50. This is 50, right? Sorry, I can know that this is 50 and take this chunk away, or I can just say if it's less than 130, what's this plus this plus this? And if I do that, that's when I add those strips together. That's how I get the answer of 16%. The other way to do it is if this is 50 and this is 50 on this side, right? So I know 50 is gone, right? So I can work backwards and say 1 subtract this is going to leave me another 50, and this piece is 34. I can also subtract that from 50 to get 16%. So either way. The next question says, what's the probability that I am greater than 170? And that is the same answer as the one before, because what you find here is these strips, 1 standard deviation in the positive direction this way is the same as 1 standard deviation in the negative direction that way. So there's symmetry here, right? So if you add those pieces up, this piece and that piece also add up to 16%. Question 4 I put over here by accident. It's at 190. Both of these are at 190. One is, what's the probability that I'm greater than 190? What's the probability that I'm less than 190? You can do one then the other. So if I do 5 first, what I can do is add the 50. So if I look at this and I go, what's the probability that I'm bigger than 190? Bigger than 190 would just be this guy plus that guy, right? So I'm at 2.5%. That's all it is. Okay. So bigger than 190 is 2.5%. All right. And then what if I did it that way, right? I got 2.5% here for bigger than 190. Then less than 190 would be 1 subtract that, because the whole thing is 1, right? So if this is 2.5%, if I do this one first, I get 2.5% here, right? That's this by adding the strips. If I go back to this one and I want to figure out what the rest of it is, this side of that 190, it'd be 1 subtract 2.5%, or 100 subtract 2.5% to get 97.5%. Or in this case, I did 5 first, so I added 50, right? And then I added the other 2 strips. I had the 34 strip and 13.5 strip to get to 190, to get 97.5 this way, and then I could subtract it from 1 on that side. The last one, same thing. You're just going to add the strips. Not same thing, but a little different. You're at 1. You're from here to here. So we have the 3 strips. We have 1 strip, 2 strips, and 3 strips. They're 34 and 34 and 13.5. And they add up to 81.5. All right, so that's it. That's how you do standard deviation. That's the whole intro. I think it's kind of cool. Z-scores are even cooler. I'll make another video soon.